Welcome to the Lighting Controls Association's online education course, A Year with a Network Lighting Control System, authored by C. Webster Marsh of Penumbra Controls. I'm Craig DeLuey, Education Director for the LCA. This course is registered with the American Institute of Architects. Education credit is recognized by the NCQLP, the DLC, and the state of California, and it is a foundational course for NALMCO's CLCP certification exam. Needless to say, this does not imply endorsement by these organizations. Check out the course at LCA's Education Express to learn more about applicable course credit, the copyright, and our standard disclaimer about this information. For course credit, you can also click the link in the description below to take the complimentary quiz. Now let's get started. This course's learning objectives include engaging with stakeholders about opportunities with network lighting controls based on an understanding of NLCs as a business tool, not just a technology. The second is to evaluate projects with an eye for lighting controls that go far beyond energy code compliance and energy cost savings. And the third is to educate owners about how ongoing interaction with NLCs can produce different benefits throughout the year. Network lighting controls, or NLCs, provide many new ways for people to interact with lighting and building-wide controls that have not been possible until now. With these new possibilities, sometimes it can be easy to get overwhelmed and not know where to begin. The great thing about these controls is that they are easy to use and you can add more programming or devices as you become accustomed to the system. The first step is to start with opportunities and requirements. This learning module was designed to help building owners and managers and electrical industry consultants visualize NLCs as tools that can be used to improve operations while also saving energy. Oftentimes, it is far easier to visualize what we can do with lighting controls in a commercial building if we understand or have experience using them where we live. Our first example of an NLC takes place in a house. Meet Paula, who loves smart technology. She has the latest gadgets such as a smartphone, smart speakers, smart thermostats, automatic shades, a smartwatch, and motion-activated sensors all around her house. Her problem is that her house is not currently equipped with any smart lighting, and she wants to control her lighting with the same interface as she uses for everything else. Paula hires a consultant to provide a system that can interface with her smart thermostat, speakers, sensors, and phone. In the summer, Paula's system responds to daylight both with automatic shades and lighting. Automatic shades cut down on glare from the sun in the living room, which has a lot of windows, while spaces without many windows can increase their brightness to avoid too much contrast when moving from a daylit room. If any settings aren't right, Paula can always go to one of the keypads installed throughout her house or pull out her smartphone to change them. In the winter, Paula's system adapts to the shortening days by using an astronomical time clock and daylight sensors. She can set up a schedule for holiday lighting. Her system also provides tunable white lighting, which changes the house's lighting throughout the day so that the light is a cooler, more focused hue of white during the day, and then becomes a warmer and more relaxing hue of white as the sun goes down. New smart speakers and thermostats will be out soon, and Paula plans to keep on top of the cutting edge. Her system will require minimal assistance when adding more devices. Additionally, the devices automatically update themselves so she doesn't have to worry that software will become outdated. Paula's user interface on her smartphone can be reprogrammed to include additions to the house should she want to add rooms. Finally, her wireless dimmer switches are rated for 10 years of operation, but her user interface will alert her when she's approaching that mark so that she can prepare to replace the batteries. Now let's shift to a larger project, a commercial building. Meet Chris, who owns a building that is occupied by various tenants, some spanning multiple floors, and others that are moving in or out of the building. He needs a robust system that can be flexible enough to add and remove tenants on an as-needed basis, while also monitoring their energy use. Chris hires a consultant who designs a system that uses a network of smart panels throughout his building. These panels communicate with a central control server located on a computer in his office, where software allows him to select each panel and monitor each tenant's energy consumption. New tenants often move in during the summer months. The lighting control panels are connected using a dynamic network, so new tenants can make use of these panels to install their own lighting and controls, and also add new panels if desired. When a tenant moves out, the panels can remain dormant, but connected to the system until a new tenant moves in and reactivates them. This way, the new tenants can easily connect to the building's network. The system is also connected to the energy grid, which provides Chris the ability to monitor electricity costs by time of day and reduce energy consumption where possible during times of peak energy costs. The energy reduction is automatic, but he defines what the system does during peak times. During the colder months, Chris's system monitors traffic at the front door using occupancy sensors. By identifying peak traffic hours, the entrance can be heated adequately so that draftiness is reduced, while also reducing energy waste during low-use times when the door remains closed most of the time. At the end of the year, Chris's system has collected data on all of his tenants, and now he has noticed that one of them is using a lot more energy than the others. Upon investigation, he identifies that the tenant has manually overridden the daylight sensors by covering them up with tape so that the lighting stays on at full all day. After a conversation with the tenant, Chris finds out that their daylight sensitivity wasn't programmed the same as on the rest of the floors and maintains a much lower brightness than it should have. A quick reprogramming session results in a happier and more energy efficient tenant. Chris's system is well prepared for future changes. By implementing an NLC system that has panels networked back to a server, he can easily add or remove control components whenever he wants, thus allowing the system to be upgraded with ease when the time comes. Additionally, if he wants to change his user interface, he can either make the changes himself or hire a programmer to create a custom user interface to control the new system. Now I'd like you to meet Jamal, a facilities manager for a famous hotel in a borough of a major metropolitan area. The hotel offers many amenities for guests and visitors. Jamal needs to be able to monitor and manage the lighting for various space types and under a variety of conditions. He hires a consultant to update his existing NLC, which already has a robust and dynamic network of devices. In the new system, he can monitor and adjust the lighting and shades in all of the spaces from his tablet, which he carries around with him everywhere he goes in the hotel. Touch screens with custom GUIs are also installed to control the restaurant, cafe, lobby, outdoor pool, and ballrooms from a nearby locked room. With these new touch screens, hotel staff can set the mood of each space by adjusting the brightness of different lights without worrying that random guests may accidentally change the lighting. During the summer, Jamal's system uses light sensors to minimize energy consumption and to give his guests a comfortable experience. Because of the bright days, Jamal doesn't want guests to be plunged into darkness when they go from outside to inside, so the vestibules and areas closest to the vestibules provide lighting that slowly adjusts people's vision to the lower levels inside the hotel. He walks around the hotel regularly to make sure the system is providing the perfect experience for his guests by using his tablet to adjust everything, such as the lighting or the temperature in each space. Jamal's hotel has more frequent ballroom reservations in the autumn months, but his staff can set up spaces quickly because they now have access to the custom touchscreen GUI, which can control all of the ballrooms from a single location. Jamal can track which public spaces are used by his guests and how frequently. Using the software, he creates a heat map and finds one of the ballrooms is used significantly less than the rest. After investigating why, he finds out that this ballroom's windows look out into a new high-rise construction site nearby. Jamal decides to use the ballroom as temporary storage until the construction is completed, which also helps the staff set up the remaining ballrooms more quickly. During the winter months, Jamal's NLC adapts to take on a warmer but less bright color tone and perceived intensity so that guests and visitors have a cozy experience inside the hotel. While the system automatically makes these adjustments, his tablet can take control of each public space so that he can adjust their settings if they need to be changed. Jamal wants to ensure that his guests never need to think about the lighting, and so he wants to be alerted immediately if lighting begins to underperform or malfunction. The system is smart enough to be able to identify malfunctioning lights and alert him. The system also identifies when lighting is reaching its end of life and should be replaced. Jamal's system may need some tradespeople to upgrade everything in his system, but because most of the devices on his system use common connectors for power and data, the touchscreens and sensors are easily swapped out with newer versions. Additionally, by adding wireless nodes to the building, he can add wireless sensors and switches that don't require wiring of any kind so that the new devices can be added whenever and wherever he needs. Now I'd like you to meet Imani, who is CFO of a major car manufacturer that has several locations scattered around the country. Her company owns and runs facilities to assemble and store the cars, plus several office buildings including the headquarters sales floors and staff parking lots and garages. She wants a system that can control different building types and can collect usage data so that she can track building occupancy and energy use. Using this data, Imani can evaluate the utilization and efficiency of each building. The consultant she hires designs an NLC system that connects to the internet so that she can see and control all lighting at every location. The NLC provided has a central server at each building which connects to a network of devices. Each server and connected space operates independently, but Imani can change the programming from her laptop so that energy efficient measures can be tuned as needed. During the summer, Imani's system uses data collected from the light sensors and dimmer switches in the warehouse to inform her whether electric lighting is needed during the bright sunny days. She finds that in combination with the skylights in the warehouse, she can dim the lighting to 50% of their full brightness, while still providing plenty of light for the workers, which cuts down on energy usage. Employees at Imani's company often work in open office environments where they have shared lighting, but she wants to provide them with individual control for the lighting directly over their desks. With the NLC, occupants have remote dimmers so that they can customize how much light they have, which becomes essential during the winter months when there is less daylight. All lighting in these spaces turns off when the occupancy sensors time out. Since Imani is not able to be physically everywhere at once, she needs a way to monitor how each building is being utilized. Her NLC provides her with robust data showing her which spaces are currently in use and historical data of which spaces are most used or rarely if ever used. With this data, she can see which rooms or even floors are most popular or underutilized and use this data to plan renovations that reduce overhead and expand the more frequented spaces. At the end of the year, Imani's system has 12 months of data to review. Her user interface provides her with an easy way to present this data to the CEO, the board of trustees, and investors of the company. With this data, she can show off how much energy the company has saved by implementing an NLC and can also project new savings based on future decisions, such as telecommuting for southern states during the summer and for northern states during the winter to reduce energy consumption. Being connected to the cloud, Imani's system can work with a variety of manufacturers and any new technology. She can increase her granularity of data by increasing the number of sensors at each building. She can also add new buildings to her system and even duplicate a design from one building to the next. Meet Valentina, a nurse at a healthcare facility that provides short and long-term care. The facilities manager hired a consultant to design a lighting control system who asked to interview the staff to understand their needs. Informed by these interviews, the consultant provides a design for a lighting control system that is dynamic and can respond to staff needs during emergency moments while also providing control for her patients. Keypads are installed at the entrance to each patient room and touch screens at each patient's bed. The keypads at the entrances provide presets for nurses to turn on lighting for different purposes, such as floor lighting when checking on the patient at night, which would not disturb their sleep, and emergency lighting that adds a lot of light on the patient's bed to increase visibility. The lighting controls and lights in the patient's room can change to provide a warmer or cooler white, which creates a color shift that mimics the daylight cycle in the patient's room. This is an automatic feature based on time of day and is comforting to many of the patients, but this feature can also be turned on or off in addition to the lights from the patient's touchscreen. Valentina wants to make sure her patients are comfortable, especially when outdoor temperature and humidity can quickly change over a short time. The NLC sensor alarms whenever the temperature or humidity in a patient's room is too high or low, so that she can check that the patient is comfortable or if maintenance needs to fix something. One more feature of this NLC system is that it offers indoor positioning, which allows for people to find their way through the hospital. This is most helpful for visitors or patients unfamiliar with the facility who can open an app on their smartphone and find their way to the correct room. Additionally, with indoor positioning, staff can track certain assets in the facility's inventory. Staff can use a nearby computer or smartphone to locate what they're looking for. In this way, important equipment such as respirators can be quickly located in the event one is urgently needed. Administrators can use the inventory to identify which equipment is more heavily used and where, so that equipment can be stored where it is more commonly used. Finally, due to increased awareness of contagions such as COVID-19, the hospital uses the NLC to track traffic patterns and identify which rooms have been recently used. With this data, cleaning crews can identify which rooms need cleaning due to recent or heavy use. Staff can review the data to see which rooms have been cleaned and which rooms are still waiting to be cleaned while avoiding heavy traffic areas. Meet Manuel, a city official who is responsible for various functions of a city, including the lighting of a well-known bridge that is a city landmark and carries thousands of daily commuters. While a source of pride for the city, the bridge did not have any nighttime appearance until a consultant was hired to add some flair to the once dark architecture. The consultant presented a design that would add lighting, that would change color and create movement to the outside of the bridge. With this new design, the iconic bridge can celebrate the holidays or show support for local sports teams on game night, which everyone passing by can see. When the project is completed, Manuel is given secure web access to the bridge's lighting controls via his laptop, where he can change the active effect and color of the lighting. For example, Manuel wants to show support for local sports teams on game nights. His custom user interface provides an array of pre-recorded effects for the bridge lighting. He can have an effect that celebrates each team's game night with the team colors, and he can also trigger an effect if the team wins that makes the colors scroll across the bridge and flash. These effects are available in a menu on his user interface with appropriately named buttons. Manuel's system provides data on the lights mounted to the bridge and the current status, intensity, and color. An alert is sent to Manuel and his maintenance crew if a light fixture malfunctions or fails to respond, which ensures problems are resolved quickly. This allows Manuel to focus on his other duties with peace of mind for the bridge's lighting. This course provided a quick review of how a network lighting control system can contribute to a wide variety of projects and settings, but the possibilities are nearly limitless. NLCs provide easy-to-use controls and a flexible design, and they can be custom designed to meet the needs of your project. Hopefully by now you can better visualize your ideal control system and how you want to interact with it. Now let's wrap this up. Network lighting controls can maximize energy savings and simplify energy code compliance, but their utility goes much farther than that. The most advanced NLCs can collect energy and building data and also provide services such as indoor positioning and asset tracking. As a result, when engaging stakeholders about NLCs, it is useful to look at the full opportunity offered. Because these benefits are emerging and may not yet be fully understood, this dialogue should focus on applications, centering on the key question: if you had more control over lighting and access to building data, what could it do for you? This course is accredited by or registered with industry organizations. This course is registered with the American Institute of Architects. Education credit is recognized by the NCQLP in the state of California, and it is a foundational course for NALMCO's CLCP certification exam. LCA is further recognized as an education provider by the Design Lights Consortium. You can learn more about this at our website, lightingcontrolsassociation.org. To earn education credit for this course, click the link in the video description to take a quiz. A passing grade of 80% for AIA and 70% for all other recognizing organizations qualifies you for education certificates. Registration with Education Express is required. Now a brief word about the creators of this course, the Lighting Controls Association. We are the voice of the lighting controls industry, a council of the National Electrical Manufacturers Association formed to educate the public about lighting control technology and application. Our hallmark program is Education Express, a series of web-based courses on a wide range of topics. At our website, you can find this and plenty more, including articles, new product introductions, award-winning projects featuring controls, and more, all at lightingcontrolsassociation.org. Thank you again for attending this course. We hope you found the information useful for your business and wish you success in developing your next project using network lighting control.